Welcome to Module 2. In this module, we will explore foundational concepts and practical skills needed to develop smart contracts using Agoric. This module includes 4 main sections. We'll begin by talking about hardened JavaScript for smart contracts, understanding the best practices for writing secure and efficient smart contract code in JavaScript, focusing on the essential functions E and harden. Next, we'll dive into a tutorial with the dApp OfferUp example, where we'll learn about the structure and deployment of smart contracts in the Agoric ecosystem. We'll then explore the mechanics of digital assets, including how to create, transfer, and manage them using issuers, mints, purses, and payments. Finally, we'll dive into the concept of offers in Agoric, including offer safety, the anatomy of an offer, and handling offers within smart contracts. By the end of this module, you should have a solid understanding of these concepts, and you should feel confident in your ability to architect and deploy your own smart contracts in Agoric. Let's get started. In this module, we're going to establish a strong foundation in Agoric programming, covering 4 key areas essential for Web3 developers. We'll start by understanding the best practices for writing secure and efficient smart contract code in JavaScript. This is going to include an in-depth look at the critical functions of E and harden. We'll then look at the basics of smart contract development using the dApp OfferUp tutorial as a guide. From there, we'll explore Agoric's distributed computing model and understand how this architecture is crucial as it underpins how decentralized applications are built and operated on the Agoric platform. Finally, we'll cover working with digital assets using Agoric's ERTP, Electronic Rights Transfer Protocol. This section will include practical examples on creating and managing digital assets, such as tokens and NFTs, and understanding the concepts of brands, issuers, mints, purses, payments, and amount math. By the end of this module, you should be able to articulate these major concepts and understand how they relate to developing a smart contract in Agoric. Additionally, you will gain the skills needed to architect the smart contract application in Agoric effectively. Let's begin by diving into the essentials of hardened JavaScript. Our first section focuses on hardened JavaScript, which is crucial for developing secure and efficient smart contracts on the Agoric platform. Let's break down the key components of this section. Writing secure and efficient smart contract code in JavaScript involves adhering to a set of best practices. We'll discuss guidelines that help minimize vulnerabilities and ensure that your code is both robust and maintainable. This includes principles like minimizing authority, keeping your code minimal and auditable, and consistently using harden to freeze objects and prevent tampering. 2 of the most important functions you'll use in Agoric are the E and harden functions. The E function is used for asynchronous messaging, establishing secure and efficient interactions between objects without blocking the execution of your program. This is especially important in a distributed system where operations can be delayed due to network latency. The harden function is used to make objects immutable, meaning their state cannot be altered after they are created. This immutability is critical for maintaining security and integrity in your smart contracts. By mastering these best practices and understanding how to effectively use E and harden, you'll be well on your way to writing secure and efficient smart contracts on the Agoric platform. Let's dive deeper into these topics, starting with best practices for hardened JavaScript. Writing smart contracts in hardened JavaScript requires a disciplined approach to ensure security and efficiency. Here are some best practices to follow. First, write minimal and auditable code. Keeping your code base minimal and straightforward is crucial. This not only makes the code easier to understand and maintain, but also simplifies the process of auditing for potential security vulnerabilities. You should strive to write clear and concise code that performs only the necessary operations. Best practice number 2, use harden to freeze objects. The harden function is an essential tool in your toolkit. It freezes objects, making them immutable. This means once an object is created and hardened, its state cannot be altered, preventing unauthorized modifications and ensuring the object's integrity. Always harden objects that should not change after creation, such as configuration objects, contract terms, and critical state variables. And finally, minimize authority. Minimizing authority means limiting the power and permissions granted to objects and functions within your smart contract. By restricting what each part of your code can do, you reduce the potential attack surface for malicious actors. Ensuring that each component of your contract only has the authority it absolutely needs to perform its functions and no more. By adhering to these best practices, you'll be able to write secure, efficient, and maintainable smart contracts on the Agoric platform. Now let's move on to understanding 2 key functions in Agoric, E and harden. 2 fundamental functions in Agoric are the E and harden functions. Let's explore in more detail to understand how they contribute to the security and functionality of your smart contracts. The E function is used to send messages to objects asynchronously. In a distributed system like Agoric, operations can often involve delays due to network latency or other factors. Using E, you can make non-blocking calls, allowing your program to continue executing while waiting for a response. This is crucial for maintaining network efficiency and responsiveness in your smart contracts. Here's how it works. When you use E, you create a promise for the result of the operation. The promise is resolved once the operation completes, allowing you to handle the result without blocking the rest of your code. This method is particularly useful when interacting with remote objects or performing operations that may take an indeterminate amount of time. The harden function is used to make objects immutable. Once an object is hardened, its properties cannot be changed, added, or removed. This immutability is essential for ensuring that objects cannot be tampered with, providing a robust security mechanism for your smart contracts. When you create an object and call harden on it, you prevent any future modifications to that object. And this is particularly important for objects that represent critical state or configuration, as it guarantees their integrity throughout the contract's lifecycle. By mastering the use of E for asynchronous messaging and harden for immutability, you will significantly enhance the security and efficiency of your smart contracts. These tools are foundational to the Agoric platform and essential for any developer looking to build robust, decentralized applications. In the next section, we'll move on to our first practical example with the DApp OfferUp tutorial where we'll see these principles in action.